Okay. This is going to be sort of informal talk about discontinuities. I'm not going to go with the formal definition and really finding all the limits. And this is a sort of shorthand way to do it if you want to kind of do it this way as well. But if we look at a graph, we're looking for any types of discontinuities and what they are. Well, if I just travel along my line, so I'm starting at the left, I was starting at -3 and I moved towards -1. I know it's hard to see. Maybe I should do it more like this. Moved like that. And then I have to pick up my pencil here because if I want to continue, I have to come up here to where my closed dot is. So since I have to pick up my pencil, that's a discontinuity. And here we have to sort of jump between points. And just to sort of show you, if I fill in this hole here, I still have a discontinuity. And I also can't bring this point down because if I brought, oops, I don't even remember what it looks like. Oh wait, I can do that. Okay. If I brought this point down to fill it in, I would just have an open circle up there. That's still a discontinuity. Okay. So since I can't just fill a hole in, basically, we have a non-removable discontinuity at x equals -1. And then again, if I come across this line here, I get to an open dot. I have to pick up my pencil and start on the other side. But here, if I fill in this one dot, it would make it continuous. That is our definition of a removable discontinuity. So we have a removable discontinuity at x equals 2. And then the only other one we have to talk about is at 4, which really I should add a little bit more to this graph. I should do this as well. There we go. That makes it a little more proper. Actually, no, I'm sorry. That doesn't make it proper. I'm taking it back. Okay, but at 4, we have an open dot, but if I moved this closed dot there, I guess, yeah, I'll say that. If I move that closed dot there and I fill this in, I'm trying to think, there actually should be another part to this graph. But I can't think of what it would be. If I move that dot there, that actually does make it continuous, even though we're now left with an open hole there. There's nothing connected to that open hole, so I don't have to pick up my pencil to get to it, because it really would just go away. And that qualifies as a removable discontinuity. So we have a removable discontinuity. And this situation is more niche than the other two, so the other two are more important. Removable discontinuity at x equals 4. Okay, and there's from a graph. Now from a piecewise function, again, I'm going to do this kind of informally. What I'm actually going to check is, because we know we're going to evaluate, we know I'm going to end up saying 3 times 1 squared minus 4, and I'm going to get some number. But we know we want that number to actually be equal to our next function, because we want the limits to be the same. So I'm going to evaluate my next function, -7, also at, or I'm sorry, we should be doing -1, at -1. And if these two values are the same, then that means good stuff is happening. So I have positive 3 minus 4 equals negative 7. 3 minus 4 is negative 1 equals negative 7. And well, these are not equal. So since they're not equal, we already know that if we were, well, maybe we don't know, but if we were to sort of sketch this graph at negative 1, if we come from the left, we would have that right there. And if we come from the right, we would have that right there. So this would give us a non-removable discontinuity, which both of those are open dots because we have that there. So we have a non-removable discontinuity at x equals negative 1. And let me change the second example because I want it to do the other thing. So let me do this. Okay. So that was our negative 1. Now we're going to check our 1. Again, we'll check it by evaluating. We have negative 7 equals negative 7 times 1, which these values are equal. So when I sketch my graph, I'm going to know that at both sides I have negative 7. So it's only going to be one dot. But however, this is going to be an open dot because both of our inequality signs are not including the equal to. So I know at 1 I'm going to have a open dot, and to the left of it, it doesn't really matter, and to the right of it, it doesn't super matter either, but that's what we have. And we can see there that sketching that graph, we have a removable discontinuity at x equals, this was 1, yeah, at x equals 1. Okay, so that's removable discontinuities. Now, the final example I'm going to do is if we're given just like a big function. So right now, I can't tell immediately what's happening, but if I look and I see these x squareds, that's a big hint that I should try to factor things, which you can pause the video now to try and factor it yourself because I'm not going to go through the factoring. But when you end up factoring it, you end up with 2x plus 1 times x plus 7. Let me just make sure I'm right. 2x squared plus 14x plus 15x plus 7. Yep. And then my denominator, x plus 7, x minus 2. And now we can see that two of these factors, I have one on the numerator and one on the denominator, they simplify to 1. But I don't want to get rid of them exactly yet because this x plus 7 is still on the denominator. So let's start off with our first step. Where is the denominator 0? Where is bottom 0? Well, that means we have x plus 7 equals 0, x minus 2 equals 0, x plus 7 equals 0 implies that x equals negative 7. X minus 2 equals 0 implies that x equals 2. So those two values are where our denominator is 0. And now we just need to check, we already simplified, so I think that was actually my step 2 on the notes, but we simplified. And now for step 2, which ones, let me be more precise, not which ones, which factors simplify. Simplify, and which don't. And we sort of already did that because we saw that the x plus 7 simplified and the x minus 2 does not. So x plus 7, we removed it because it simplified, so we have a removable discontinuity. at x equals -7 and a non-removable, because we could not remove it, we couldn't simplify it, discontinuity. I really need to be more consistent with how I write non-removable at x equals 2. Sometimes I do a dash, sometimes I don't. At x equals 2. And that covers everything for discontinuities.